Baigan, welcome to the stream, dude. Oh, my camera's stuck for some reason. Let me unfreeze that. How you been, Baigan? How you been? Force and party. Let's go, baby. What is that chat overlay? It is social stream. I'm using this chat overlay because it supports multi-stream because I'm also streaming to YouTube right now. So it gets the chat from both YouTube and Twitch and puts it into one. Can't even see 7TV emotes on it. Oh man, thank you, brother. I might have to do it. Kabir, what's going on, dude? How's it going, man? Welcome back to the stream. So Kabir. So recently we've been doing these Leetcode grinds. Today we will be doing more of that. So these previous days we did some arrays and hashing problems. Yesterday I did these 2 pointers problems. I tried to do threesome, but one of my viewers said it was not safe for work because it's a threesome. So, well, that was part of that. The main reason was that it was way too hard. It was not computing in my brain. So I went over and started this stack problem, valid parentheses, not too difficult. So today we'll be continuing in the stack category. We'll do this min stack problem. And here we go. So minimum stack. Design a stack class that supports the push, pop, top, and get min operations. Min stack initializes the stack object. Sweet, I managed to get the first 25 done, then I gave up. Oh, jeez. What was the reason for giving up, Kabir? Min stack initializes the stack object. Void push pushes the element val onto the stack. Void pop removes the element on the top of the stack. And top gets the top element of the stack. Int get min retrieves the minimum elements in the stack. Interesting. The minimum element. So we need to keep track of the minimum element. Return 1. Oh, by minimum element, I think they mean the bottom element, because 1. Oh wait, they get min last, so they pop. I took too many days off, so I need to restart it. I feel you, man. I feel you. That's me with the gym. I haven't been to the gym in like a month and a half now. I need to get back in there. Yes, I am learning C#. So I told the recruiter. She asked me what object-oriented languages I know, and I told her C#, C++, and Java. I have to learn C# for the new role. Oh, geez. What is there? Are you using like ASP.NET or something for the back end in the new role? Is that why you're learning C#? I don't think I'm the biggest fan of C#. What about you, Kabir? Okay, so do have to keep track of the minimum value. Yeah, it's .NET API, React front end. Oh, you got the front end though. You got the front end down pat, dude. Pop, top, and get min will always be called on non-empty stacks. Nice. All right, so every time we push and pop onto the stack, we have to... Ooh. What happens if we push something on the stack, we have a min value, and then we pop that min value. That means we need to recalculate the min. But if that's the case, that would run in O of n time. We'll cross that hurdle when we get there. Oh, Kabir, something I want to do on stream with the particle simulator. I want to get like a bunch of images of girls and pretend that they're my exes, and then like dissolve their images in acid using your particle simulator. I think that'd be a cool little bit to do on stream, and then cut it up and put it on YouTube or something. Okay, so what data structure will we be using for this stack? I'm thinking a list. Probably an array list so that it can automatically size up and if we need to. So array list. Oh, what objects are we putting? Are they just integers? Okay, I don't know if it says that it's just integers, but I guess we'll assume so. I don't know if that'll get me in trouble in an interview, but int array list int stack equals okay, so we'll just leave it like that, and then in min stack, this is where we initialize it. So we'll set stack equal to array list int. All right, push. Oh wait, this is C#. I want to start off in Java, actually. So array list int stack equals, oh, no equals yet. Here we initialize it. Stack equals array list int push. Here we'll just do stack dot, what's the function for adding to an array list? Is it push? Oh, it's add. Dot add val. All right. You've been hitting Crusader Kings? The last time I played Crusader Kings was on that stream, dude. Oh man, I haven't touched it since, and I think that might be a good thing, because if I've touched it, I would lose buckets and buckets of time. How about you, Kabir? Have you so you became the king of Ireland, if I'm not mistaken. Have you expanded outwards? Oh, okay. Wait a second. I just had the idea of maybe sorting the stack. Man, I spent way too much time on it. Dude, every single time I play, I put in like at least like 5 hours, 8 hours. It's 12 hours. It's ridiculous, dude. It's so addicting. Yeah, King of Ireland, then King of England destroyed me. Oh no, dude. Oh jeez. by destroyed, does that mean he conquered you? I tried to take over Wales. Oh no, dude. And King of England wasn't having it, so he didn't let you take over Wales, huh? Oh man. I had about 9k army. He was on 15. That's not that big of a difference though. I'd assume the King of Ireland have like, I don't know, 3,000 army. Damn. You didn't hire any mercenaries? Okay, so I had an initial idea maybe of using a ordered list, but this wouldn't work for the pop and push operations. And I never hire mercenaries, just raw dog. So you weren't panicking when he was like, when you saw like the 15,000. That's what I usually do. I panic when I see that they have more soldiers than I do, and I just hire mercenaries. Oh. And that ended up messing me up because I couldn't afford to pay the mercenaries, and they just took over one of my counties, and I could do nothing about it. So each function should run an O one of time. To do this, I'll need to keep an ordered list and a stack. And that will take O of n storage space, which I think is fine. We'll end up implementing this, and then I'll check out what the recommended time and space complexity is. So we'll also need an ordered list. Array list int ordered, because when we pop the minimum element, we want to set the new minimum element to the next element in the ordered array. And we'll also need int min okay. So we add the value to the stack, just like that. And then we also have to go through the ordered list until value is wait a second, in the right order. Let me see. Okay, we can have negative values as well. So if we can have negative values, I'm thinking we'll store the minimum values at the end. So while val, we need a counter as well. So int counter is equal to 0, while val is less than, no, while val is greater than ordered counter plus plus. Okay, the thing about this is what happens for uninitialized elements in the ordered array. How should we sort this? If we initialize let's look at the Java array list documentation a little bit more. I don't think I'm familiar enough with array lists. So what is the array list? What are the elements initialized to? Sort an array list. Oh. Another useful class in the java.util package is the collections class, which includes the sort method for sorting lists alphabetically or numerically. Interesting. Interesting. I don't think I want to use the sort function though. I think I want to keep the putting the element in the right spot when it's added. So what is an array list initialized to? What is array list initialized to? Okay, so I think I initialized this array list and it's empty. So let's do a check. If the array list, if its size what's the size of the array list? It's just dot size. Okay. If stack dot size, if it's all right, since we're doing the ordered, let's use the ordered size just for the sake of continuity. So if order.size is equal to 0, if it's empty, we'll just add it to the list. So ordered.add val. Otherwise, if there's an item in the stack, we will else, okay, here we'll have our while loop, so we know where to put the element. And I think with an array list, you're allowed to put the element in a specific spot. So in counter is 0, while value is greater than ordered counter plus. Okay. And then we will just include the element where we want it. So set, there's set. Can you insert it within an array list? Insert into array list Java. See, I'm not sure if this is possible. Oh, you can add it like that. That's awesome. Okay, interesting. But does this make the solution different time complexity? Because this push needs to be O of 1. But if we're going through the entire array list, I wonder what the solution is to be able to, yeah, because this is O of n. This isn't correct. It needs to be O of 1 time. When this executes, when we push something to the array, this will go through, if it has to. In the worst case, it'll go through all elements in the ordered array, which is n, O of n. Is there a way? How can we keep track of the minimum element in the array? And when that element gets popped, how do we calculate the new minimum in O of 1 time without having a sorted array? Huh, interesting. All right, we will just do a silly implementation right now that doesn't really do min correctly, but just to keep going until we get there. So stack.addValue, here we'll just check if stack is empty. If stack.size is equal to 0, we set it to min. Min equals val, and we'll add it to val. All right. And also we'll check if it's minimum. Else if min is, if val is less than min. Oh, wait a second. Could that just be solved by having two, like int min and int before min? And then, wait, no, I don't think so. Because how do you, so then when you add a new element to the list, you check if it's min wouldn't exist. All right, let's draw this out. So you have a stack. You pop something in there, 2. So now it's on the bottom. And then 3. And min is equal to 2. Then you pop a 3. All right, you check if it's less than 2, it isn't. And then you put in a 1. So 1 is less than 2, so now you set min equal to 1. So when min is replaced, should we have a backup? Or if we have, let's say, previous min, let's say second min. Second min, so we pop 2 in, we push 2 in, and we'll set it both to 2. Then 3. Is 3 less than 2 or 2? No. What about 1? Yes. So now we check, is 1 less than 2 for min? So we change it to 1. And we stop there. Okay, say we pop out 1. So now the minimum is not 1 anymore. So we'll check. Pop 1. Is pop the min? I mean, is 1 the min? Is the value we just popped the min? If it is, move to min to min. All right. So then we add 2. But then what do we do for 2 min? We just, I don't think that works. But it'll bubble to the brain once we're ready. Else if okay, so where were we? So if stack size, okay. Else if value is less than min, so if value is less than min, we set min equal to value. All right, and then we add it. So that this, let's say it works. Doesn't return anything. All right, pop. Okay, so what do we want for pop? We want to, this also doesn't return anything, so it's the C++ implementation of stack. So this just deletes the first element in the list. So what is it? Remove element from ArrayList Java. Is it just .remove? Either by position or by value. Right. So we'll just remove 0. And pop will always be called on a non-empty stack, so we don't need to check if it's empty. We can just call stack.remove 0. Top, we just return stack.get 0. Int get min, return min. Okay, for our pop function, we will have to manage the min stuff. So if, well, before we remove it, if stack.get 0 is equal to min, then we need a new min. Maybe I need to draw something out with a pen and paper. Do I have a pen somewhere? I have a pencil. I guess pencil's good enough. I have some note cards I can use. This has to be possible since they say each function should run in an O of 1 time. Each function should run an O of 1 time. That means we can't sort any array, any list. We can't sort it because sorting it will take O of n. All right, I'm going to need a hint. Let's look at the recommended time and space complexity. You should aim for a solution of O1 time for each function call and O of n space, where n is the maximum number of elements present in the stack. Okay, yeah. Hint 1. A brute force solution would be to check for the minimum element in the stack for the getMin function call. Yeah, that would be an O of n approach. Maybe O of n extra space to store some information. Okay, we used up one hint that we already knew. Maybe this might help us. Maybe O of n extra space to store some information. That's what I'm doing, a little extra space. I keep track of the min variable, but how do you update it when an element gets popped? How do you update it when the min element gets popped? That's... Oh. If the min element gets popped, then you're screwed. You'd have to recalculate. And that would take O of n. All right, hint number 2. I still have no idea. We can use a stack to maintain the elements, but how can we find the minimum element at any given time? Perhaps we should consider a prefix approach. A prefix approach. Wouldn't that take O of n time, having a prefix approach? If you had a prefix array and you push to it if the value is min, it wouldn't be ordered. Hint 3. We use an additional stack to maintain the prefix minimum element. When popping elements from the main stack, we should also pop from this stack. However, when pushing onto the extra stack, we should push the minimum of the top element We use an additional stack to maintain the prefix minimum element. When popping elements from the main stack, we should also pop from this extra stack. However, when pushing onto this extra stack, we should push the minimum of the top element of the extra stack and the current element onto this extra stack. What? Okay, you use an additional stack to maintain the prefix minimum element. When popping elements from the main stack, we should also pop from this extra stack. However, when pushing onto the extra stack, we should push the minimum of the top element Interesting. I guess I'm an idiot. I need to look at the solution. Okay, so the brute force solution, they have a variable that keeps track of the smallest element, and it goes through the entire stack. O of n for get min and O of 1 for other operations. Yep. 2 stacks. All right, so there's a stack and there's a min stack. Oh, and they just used a stack for this class, which I thought might have been cheating, but whatever. Push. So stack.push puts the element into the stack. If min stack is empty or value is less than min stack.peak, min stack.push. So if it's empty or the value is less than or equal to min stack.peak, okay. So the first element, all right, say the first element is 5. There's nothing in there, so we just put it in. Boom. And then the next element is 3. Min, and then we got normal. All right, so you put 5 in there. There's nothing in there, so it gets in there. And then you put a 3. So now there's a 3 in there. And then the normal stack, there's a 5 and a 3. And then, say you push a 4. In the normal stack, it enters in the normal stack, so 4 is at the top, but there's nothing in the min. And then say you push another 5. Now, how would popping that work? So now that 5 and 4 aren't in there, and even though 4 is the second minimum, it's a 5 that's in that stack. All right, pop. If stack's empty, return true. Int top equals stack.pop. All right, so we pop. We call get min, and we get 3, because it's the top of the min stack. At this state, we pop. If top equals we pop, it's 5. Is it equal to min stack.peak? No. So we don't pop from the min stack, but we pop through here. Ah, okay. I'm starting to understand it. What the heck is up with my camera? Okay. So since since we have to pop to be able to get down to the minimum element, it's safe. All right. That makes sense. Since every other element that's added after that can be smaller or bigger, if it's smaller, it'll be added to the stack. Okay, I get it. That's pretty clever. That's pretty clever. So, without looking at the solution, and if I understand it correctly, I should be able to implement it. Let me use 2 stacks instead of this array list implementation. So stack int stack. And then we've got the min stack. So stack int min stack. We'll initialize both stacks. Okay, pushing the value would require us to push the item onto the stack. So on the normal stack, stack dot push val, and if bin stack dot is empty, or val is less than stack dot peak, min stack dot push val. Okay. Man, my brain was stuck on it needs to be an ordered list, and that takes O of n time. Oh man, how do you? This is a very clever solution. Very interesting. My simple brain can only think of the damn brute force solutions. All right, so pop. If we want to remove the last element, and when we remove this element, we also need to check if it's less than the top element. So int min equals min stack dot peak if min is if stack dot peak is less than is equal to min. If those elements are equal, then we need to pop from the min stack as well. Otherwise, we can we could pop the main stack from here. Stack dot pop. All right. Return stack dot peak. Return min stack dot peak. All right, let's run this. All right, before we run it, let's just go over the code a little bit. So we have our stack and our min stack. When we initialize the min stack class, we create a new stack and a new min stack, both initialized with integers. Our push function it pushes the value onto the normal stack, and if the minimum stack is empty or if the value is less, oh, here we caught something. This needs to be less than the min stack dot peak. The value is less than the min stack dot peak. We push the value onto the min stack. All right, now when we pop, we check, we get the minimum value. If the stack item that we're popping is the minimum value, then we also pop it from the min stack as well as the normal stack. Top returns the top of the normal element, the normal stack, and get min returns the minimum element. All right, run. Unexpected type. Is int not allowed? Stack of ints. We have to use integer, don't we? It has to be a raw stack, or you can use list stack your class list stack. All right, so we'll use integer. Integer. Why don't I get pretty colors? All right, so we passed the first case. Because of the solution. Oh, empty stack exception. I thought none of these values were going to be, none of these functions were going to be called on an empty stack. Oh, interesting. Pop, top, and get min will always be called on non-empty stacks. Interesting. All right, so initialize the stack. It pushes a -2. It pushes another -2. It pushes a -3, pushes a -3, get min is -3, pop is -3, oh, whoops, I have an error in my code. This should be less than or equal to min stack dot peak because yeah, because it's the minimum. It doesn't get added. Nice. Java solution has been accomplished. Now let's do the same thing in C++. So, we need a stack in C++. Let's see. I need a cheat sheet here just to have all the data structures and functions for C++, Java, and C#, just so I could save some time. Stack C++. So stack in my stack, huh? Cool. Stack int stack, and then the min stack int min stack. All right, min stack will initialize both stacks. There's no new keyword, is there? Interesting. Do I just call these in here? I think there's going to be some out of scope errors if that stays like that, but let's continue on and we'll cross that road when we get there. When we push a value to the stack, we just push it onto the normal stack, and if min stack dot empty or min stack dot, in C++, I think the to get the element you just check top, min stack dot top value is less than or equal to min stack dot top. If that's the case, then we push it onto the min stack as well. Min stack dot push val. Nice. And it's a void element, so we don't return anything. And now when we pop, so we pop it from the normal stack, stack.pop. You know what, before that, let's get the minimum. Int min equals min stack dot peak, or I mean dot top, sorry. If stack dot top is equal to min, then we pop from the min stack as well. Min stack dot pop. Okay, and then we pop from the normal stack. Stack dot pop. Now to get the top, we just return stack dot top, and min we return min stack dot top. All right, let's just go over it and make sure we've written everything correctly. So we create the normal stack and the minimum stack. When we push a value, we push it to the normal stack, and if the minimum stack is empty, then we push it, or if the value is less than or equal to the min, we push it as well. Then when we pop, we get the minimum value. We check if the top of the normal stack is the minimum. If it is, we pop it from the minimum, and we pop it from the normal stack. We return the stack on top and the minimum. Okay. Compilation error. Okay. Error expected primary expression before int. Missing template arguments before dot token. Min stack was not declared in the scope. Okay. So when we initialize, C++ fields in class. Let's see what the preferred way is. So I guess you make a private interesting. What is that constructor for, though? C++ constructor. My class, it just prints. Interesting. Does the constructor just do nothing in this case? The constructor just doesn't do anything. Now we run that, and it should work. No, there's still a compilation error. Interesting. What does the function say? In C++, they initialize it. Okay, so the constructor is empty. They make them private variables, which makes sense. They define it with the standard library. Okay, so private standard stack int stack, and standard stack int min stack. I haven't had to use the standard library declaration like that before this. All right, so that passes, and if we submit, that passes as well. So now let's get the C# implementation going. This is my old code. Remove this stuff. All right, so is this how we make a stack in C#? Stack min stack, and now when we initialize it, the constructor, we can just do stack equals new stack int min stack. All right. So now when we push, the same logic, just written in C#. Stack.push val if min stack dot, let's see what the functions are in C#. Stack C#. Dot push. Okay, that's how we initialize a stack in C#. Nice. And we have push. We have push pop. Do we have peek? C# peak. Okay, there's a peak method. Nice. So min stack dot count is equal to 0, or min or val is less than min stack, less than or equal to min stack dot peak. And we push it. Min stack dot push. Cool. Now pop. Int min equals min stack dot peak if min is equal to the normal stack top element, then we pop from the min stack. Min stack dot pop. And then we pop from the normal stack. Stack dot pop. And then the top function is just the peak function for the normal stack. So stack dot peak. We got to return that. The get min is the same thing, but for the min stack. Min stack dot peak. Run. Hey, let's go. First try, no compilation errors. And submit. Let's go, baby. Too easy. No, but coming up with the solution to this, coming up with the stack, having a min stack, and just the way it works, I just didn't think it would work because I thought it wouldn't correctly track the minimum element at any given moment. But it does. Okay, so let's do the next one. Let's do, so we could do another stack one, which I could do because I didn't really solve this one. I relied heavily on the hints. Evaluate reverse Polish notation. Interesting. Let's do it. Evaluate reverse Polish notation. You are given an array of strings, tokens, that represent a valid arithmetic expression in reverse Polish notation. Okay. Return the integer that represents the evaluation of the expression. The operands may be integers or the results of other operations. The operators include plus, minus, multiplication, and division. Assume that division between integers always truncates towards 0. Okay. Right, reverse Polish notation. So output is 5. So 1 plus 2 times 3 minus 4. Okay. I get how that works. So we need to output the answer. So there's going to be between 1 and 1,000 tokens. And tokens is these or these? Okay. So, first plan of thought is we have a there's nothing about the time and space complexity, but initial thought, we have two stacks, a integer stack and a operator stack. We come across an integer, we put it in the integer stack. So right now the stack would be 1, and you push that 2, and then an operator stack. So that goes into the plus. Let's do this with drawing. So we have a stack integer, and then we have a stack operator. So 1, 2, then plus, then 3, then star, then 4, and minus. All right, so once we fill the stacks, then we could start popping them. You know what? I don't think we need this operator stack. I think we can do it so that we just have a stack. Is the current element a number? If it is, put it in the stack. It is, put it in the stack. It's not, it's plus. Then we pop 2 elements from the stack. We pop plus 2 and 1, and we get the solution 3. Then we put that in the stack. And then we come across another 3, so we put that in the stack as well. All right, we come across a multiplication operator. So we pop 2 elements from the stack. 3, 3. It's 9. Okay, we put that back in the stack. Then a 4. Okay, and then we come across this 9 minus 4. Okay, cool. So we'll start in Java. So we'll create a stack here. And this is a O of n solution, and we don't really use more than 2 elements at a time. So O of 1 space. Okay, so let's make our stack. Stack integer, and we'll call it numbers. We have to initialize it. Okay. So great. So now we'll have a for loop for int I equals 0. I is less than tokens dot length, and then I plus plus. All right. So it is a string, so we need to do a parse int, I'm pretty sure. But all right, so if tokens I is equal to plus, it's a string, not a car, plus, or tokens I is equal to minus, or tokens I is equal to multiplication, or tokens I is equal to division. If it's any of that, then we want to pop 2 elements from the stack. So int operator, not operator, int integer 1. Can we do this in one line of code? Interesting. Numbers dot push numbers dot pop Oh, are we gonna have to do this 4 separate times? Plus numbers, I think we'll have to just split this up actually. Numbers.pop plus numbers.pop. Else if tokens I is equal to minus. Else if tokens I is equal to multiplication. Else if tokens I is equal to division. All right, and with the division, we truncate towards 0. That happens by default, thankfully. And now here we will just change the operator for each one. So this is minus, so we want to subtract. Also, would this be correct? Yes, the first. Is it in reverse actually? So 3, we pop the 3, we put another 3 on it for minus actually. So this is 9. So 9's at the bottom, 4 is at the top. Numbers.pop would be 4 would be 4 minus 9. Okay. So it's kind of a reverse order. So int second equals numbers dot pop, and then we'll do plus second. It doesn't really matter for addition. But it matters for subtraction. Bruh, what? All right. This needs to be multiplication. This needs to be division. And I need to copy this over. And remove this. Cool. So that should be the logic for when we come across a plus operator. Otherwise, it's always going to be a number. So we will push numbers.push. We will push the parse int. Is it integer.parse int tokens I? Right, and then we will return there should be only one left, so we'll return numbers.pop. So we'll go over this real quick. We create a stack of type integers. and then we go through the tokens list. If it's addition, we pop the second number, and then we push the first number plus the second. And we do that the same thing for minus. Same thing for multiplication. The same thing for division. But if it's not any of these operators, then we push the number, parsed as an int, onto the stack. And at the end, we return the last integer, which is the solution that gets popped on. So let's run it. Compilation error. Yep, dot length doesn't exist. I think it's dot size, since we're in Java. Oh, it's not size either. Oh, is it just dot length? Not a function. It's a property. Silly me. For input string. Oh, interesting. Parse int. If tokens I is equal to plus. Ah, silly. Wait, no. I'm putting the numbers in as integers. What I should really have here is probably a switch statement. That would make it a little more readable. But what? For input string plus $29. Why are we getting a number format exception for parse int? Let's see. Parse int Java. All right. Let's just print system.out.print ln hi. Should get a hi. Oh, whoops. What the heck? All right, so there's something I'm doing wrong here. We get a string array of tokens. Then we go through it. If tokens I is equal to plus, it's not. Is it equal to minus? It's not. Is it equal to star? It's not. Is it equal to slash? It's not. Else, numbers.push integer.parseInt tokens I, which should be 1. Let's print here. Run that. We got a runtime exception. Okay, we print hi. Hi. Okay, so it tries to add this. Okay, should I just copy and paste it from here? Maybe it's some weird error. What? Let me just copy it from here. For input string. Why is it trying to parse it as an integer? I clearly tell you if it's equal to am I doing that wrong? Should it be dot equals? Compare strings Java. Yeah, dot equals. All right. Silly me. Dot equals. Dot equals. Dot equals. Okay, now if we run it. Nice. Accepted case 1. All right, we can remove this print since we know that that executes. And let's submit. No way. Okay. Now, do we do this? Have we solved it correctly? Do we use the recommended time and space complexity? What is with my camera? You should aim for a solution of O of n time and O of n space where n is the input array. Okay, yeah. We use less than O of n space. We only use we only use, what's it called, 2 things at a time, 2 slots in a stack at a time. So is there better? Brute force. While tokens dot size is greater than 1. Let's put the Java solution up. Oh, interesting. So they make a, oh, this is a brute force solution anyways. Okay, so array list. Interesting. This, I don't like that way. It's yucky. Oh, this takes O of n squared time. That's just complicated. Ugh. A doubly linked list. Interesting. O of n, O space n, O, and then there's recursion. Yeah, recursion would be a cool solution. And then there's the stack solution. There we go. There's a bunch of different solutions. I used a stack because the category was called stack. This was honestly not that bad of a problem. Not that bad of a problem. Let's do this in C++ now. So we'll create a stack that's private. Stack of ints. We'll call it numbers. Great. So we have a vector of strings called tokens. So we will do the same thing, for loop in I equals 0. I is less than tokens dot size. I plus plus. As C++ is the language that you can either use size or length, I'm pretty sure. So this string stuff, I wonder if there's a dot equals for C++, or if it's you can just use the double equals operator. So let's check it out. So if tokens I is equal to, let's just be sure, string equals C++. Oh, it can be compared for equality using the equals. Nice. If tokens I is equal to plus, then we push. Oh, we also need to get the second. Well, it doesn't really matter that much for addition, so we can just do numbers dot push numbers dot pop plus numbers dot pop. If tokens I is equal to minus, it matters for minus, so we need to get the second, equals numbers dot pop, and then we can push numbers dot push. We could push numbers dot pop minus second. Else, if tokens I is equal to multiplication. All right, with multiplication, it doesn't matter, so we could just push numbers dot pop times numbers dot pop. But for division, it does matter. So we need to pop out the element and keep it there. And then when we do the actual operation, we can pop numbers dot pop. We can pop numbers, get the second one, and then divide it by, the first one, and then divide it by the second one. Awesome. And if none of that is true, then we know it's a number. So we push, is it A to I? A to I. Parse int C++. It's S to I, okay. A to I, what's A to I? S to I, tokens I. Okay. And then we return the last element. So return numbers dot pop. Okay, so we go through the list of tokens. If it's equal to plus, we add them. If it's subtraction, we subtract them. If it's multiplication, we multiply them. If it's division, we divide them. Otherwise, it's none of those operators. It's got to be an integer. So we push the integer, push the string converted to an integer onto the stack. And then when we are done, we pop the last element from the stack because it is our result. So we run that. We have a compilation error. Stack does not name a type. Yes, we forget to use the standard library. Now we run it. I forgot this about C. Pop just removes Okay. Okay, I forgot this about C++. So we need to get the elements from the stack using top, and then pop them from the stack. So we will int, what is it, numbers 1. Number 1 equals numbers dot top, and then pop it, numbers dot pop. APU, welcome back to the stream. It's going pretty good. We solved this reverse Polish notation problem pretty quickly in Java. So now we're just doing the solution in C++. Have you been? You were you able to get your problems done yesterday? And then the number 2 is equal to the second element of the stack. Good. Was just working on some problems. Hell yeah. What you're at 464. Holy cow, dude. Holy cow. Trying to end at 470. So you're trying to, how many Leetcode problems do you do a day, dude? Or you're on Leetcode, right? You use Leetcode. Numbers dot pop. All right, so now we'll do number 1 plus number 2. Try to do 10 a day. Holy cow. How long does that take you? Leetcode, the Leetcode problems are in Leetcode as well. Yeah. Okay, cool. Yeah, trying to get your profile up like BetSimp, huh? Holy cow. Can you imagine solving every single Leetcode problem? That's insane to me. Like there's 3,200 problems. If you do 10 a day. Oh, if you do 10 a day, you could get that done in a year, can't you? 10 times 365. Yeah, you could get that done in a year, actually. You're on track, dude. Hard to say because I break it up throughout the day. That's probably the way to do it, instead of doing it all at once. Just did about 90 minutes and about to take a break. Hell yeah. So we got to do the same thing for here. We'll just copy this. Then we'll do for a few more hours, then another break, then another few hours. Wow. So you basically do Leetcode all day, if I'm not mistaken. You just split it up and take breaks in between. Yeah, and apply for jobs. Hell yeah. It's a grind, man. I was laid off in November, so just grinding to get a job. Yeah. Have you had any interviews? What? Also, what company were you working at before? Yeah, one interview passed everything but couldn't get salary requirement to line up. Dang, dude. So back to looking, that's tough. I was working at a startup that makes software for data scientists. Was there for 9 years. Wow. Are you trying to find another startup to work at, or you want like a big company now? I hear the startups are a lot of work, a lot of hours. Not sure, taking it case by case. Cool. You're flexible with that, I guess. right, so since pop doesn't exist, I mean, since it returns void, I switched that up to use top and then pop. So now I'll see if this compiles. Learn by necessity, otherwise. Oh, I worked at Google for a year but wanted more responsibility. Worked at 2 startups, very chaotic but can be a lot of fun and you learn a lot. Learn by necessity, otherwise everything crashes and burns. Interesting, yeah. I feel like I kind of want to work at a startup. I feel like it'd be fun. Yeah, learn all that stuff. Run around, having like a solid team to work with. Maybe eventually. Void value not ignored as it ought to be. Silly me. It's top, not pop. Went back to the hotel. Oh wait, I had to work 30 hours straight once. Holy cow. Went back to the hotel, slept for 6 hours, and came back and worked 20 hours. It can be exhausting, but also so much fun. Holy cow, dude. Wow. Was this at the software for data scientists company? Was it another startup? Okay, so we have an error. Wow. Those data scientists need their software tools, dude. We were working on a project for PwC. Oh. Ah. Alright, so for this case, we get a -5 instead of +5. Because this is backwards. Picture from that day. Oh my god, dude. Is that someone sleeping? Oh, the pizza and the Coke. That's a vibe, dude. Oh my god. That's a vibe, though. Oh, man. It reminds me of like a hackathon. I was never able to do a hackathon. That's a coworker that fell asleep on his shoe for some reason. He used his pillow. He used his shoe as a pillow. Oh my god. Yeah, he said he was just going to lay down for a second. Dude, that's hilarious. Oh, I kind of wanna. That's like hackathon energy. I've never been. I've only done hackathons online because when I got into hackathons, it was COVID. So I feel like it'd be so fun to go to like a hackathon and have like this sort of vibe. This pizza, laying down on the floor sleeping. It's an aesthetic. It's an aesthetic for sure. So this needs to actually be number 2. This actually needs to be number 1. See, that's why reusing code is important. So I don't have to make these changes everywhere. Just make them once, but I reused it. I probably should have made a function. This was the view from that office. Super fun times. Holy cow. That's nice. Wow. Where is this? This is beautiful. Holy cow. That's the Thames. It's the London Eye. No way. We got another UK guy? Dang. Kabir Sink and 80 Eastwood. You got a new friend. You got a new buddy here. Wow. That's the London Eye. Wow. No, I'm from the Bay Area. Oh, geez, they sent me to their office to work there. Holy cow! So you're from the Bay Area and they sent you to London, dude? That's crazy. That's so cool. How long were you in London for? C# time. Prague, Sydney, London, Frankfurt. Come on, dude. That's crazy. Wow. That's epic. You went to Sydney for 3.5 weeks? You and your entire family, dude? Holy cow. That's epic. I kind of want to find a job like that where I could travel. Oh, man. It's easier for me because I don't have a family to take with me. Wow. So you were with your family in Sydney for almost a month. That's pretty epic, dude. That's pretty epic. I had to haul my 3 kids and wife there. Yeah, that's that's a big thing to do. Does your wife have a job as well? When they would come with me, they would travel around while I worked. And was it during the summer? Like, don't your kids have to go to school or something? That's a good deal, traveling around while the man of the house is working away, eating pizza. She's a nurse, but she worked per diem at the time. Interesting. What does per diem mean? Yeah, summertime. I tried to coordinate with school breaks. Hell yeah. Per diem, daily allowance of money for expenses while traveling for work. Interesting. Or sometimes just take them out of school since it felt like a good learning experience for them. Yes. Yes. I'm sure those kids learn a lot more from traveling to those countries than sitting in a classroom. It means she made her own schedule. Basically, she puts herself on the schedule on days she wants to work. Oh, that's cool. That's cool. That a nurse per diem, so you get to make your own schedule. I wonder if is that the same way probably like flight attendants get their work done. That's epic though. That's epic. Okay, so C# solution. Get our for loop going. I is less than tokens dot count. Yeah, it was epic, but now it's over. Yeah, until you find a new place to work. Exactly. So you've been searching since November. It's tough out here, man. It's tough. I wonder what the C# string comparison is. No, just started looking. Oh, okay, cool. And you've already had an interview in a week. Oh, you're chilling, dude. Oh, you're chilling. You'll find something soon. They gave me some months of severance and I took some time off. Hell yeah. Hell yeah. It's been exhausting startup years, so just relax for a while. I mean, yeah, that's the way to do it. If you've saved up all that money and you've got your severance, and might as well enjoy your time. Because when are you going to get the chance to do that again? When is a company going to give you all this money in severance? You got to enjoy it a little bit. Yeah, exactly. It's going to be back to grinding soon, so just hanging out during the holidays. Hell yeah. Yeah, so you're back on the grind. Doing Leetcode every day. All day. Not sleeping on shoes, exactly. Oh. Alright, so C# is a stack. I think you can use peek and pop. Does pop return in C#? Nice. Sleeping on shoes. Yeah, that's crazy for having a family and working at a startup for 9 years and then like having these 60-hour nights. That's crazy. Going to make some coffee and get back to doing problems. Hell yeah, APU. Thank you for dropping by. I appreciate it. Good luck with your problems as well. Numbers offer, so numbers dot pop plus, oh, it's capital. Can't forget that about C#. Oh, they love their capital letters. Numbers dot will pop by every once in a while. Oh yeah, man. When I execute pop, I return value. Hell yeah. You do. Yeah, get those Leetcode problems done, dude. And those job applications. Good luck, brother. Good luck. Else, if tokens I is equal to minus, then we want to get the second one out first. So int second equals numbers dot pop. Right, and then we'll push numbers dot push. We'll push the next element on the stack minus the second number that we already popped out. Else if tokens I is equal to multiplication, then we just push the both numbers, and it doesn't really matter what order we multiply them in. So we'll just multiply them like that. And then for division, it does matter. So we will push, we need to get the second number out of the stack. So int second equals numbers dot pop. And then we'll push the result of that to the stack, which is numbers dot pop divided by the second number. Okay, otherwise, if it's none of these operators, then we can assume it's a number, so we'll push the number onto the stack, but we need to parse it first. So how do we parse parse integer? Ukansa! Welcome to the stream. Thank you for popping in. Can I bother you for a second? Sure. What's going on? How can I convert string to int? Yes, we need to know how to do that. 32.parse. All right. Do you by any chance know anything about networking? A little bit. You could ask me your question. I could see if I know the answer or figure it out with you. So int 32 dot parse. Int 32 dot parse. All right, and then we'll put in the current token we're on. Now after we execute that loop, we'll return the last element in the stack. Numbers.pop. All right, so going over it. Oh, we never actually make a stack. That's funny. So let's make that stack. Basically, I have the D drive in my desktop, and I'd like to share it to my laptop so I can transfer files seamlessly without using Google Drive. Oh, you just want to move files over from your D drive to your laptop? There's some ways you could do that. So if you have a flash drive, you could just move the files over, put them on a flash drive. But if you want to do it over the internet, let's see. Let's see what you could do about that if you want to transfer it over Wi-Fi or something. Transfer files from one PC to another. So yeah, you could use a USB drive. How can you share it directly over the network though? The file is 50 gigabytes and USB sticks are slow. I have fast internet though. Interesting. Are they both Windows PCs? Are they both on Windows? Yes, they are. That's good. So you could connect the two to a network switch or router. Okay, as long as they're both Windows. Do they both have Ethernet ports? And do you have an Ethernet cable? Nope, the laptop does not. Interesting. So let's see, you can set up a network drive. Setting up network drive. Windows. The desktop does and is connected via that. All right. How do I share folders over a network? All right, so right click or long press a file and then select show more options, give access. Of course, uConsa. Of course. Select a user on the network to share the file with, or select everyone to give all network users access to the file. Okay. You try this, uConsa, and you let me know. So right click on the folder you want transferred and then give access to then specific people. And you probably need you probably need to be on the same network for that. And also you might need to turn on network discovery. Jeter JP, welcome to the stream. How's it going, bro? How's it going, bro? So I haven't actually made my stack yet. We gotta do that. I think we can initialize the stack like this, and we'll call it numbers. I have tried that already. Then when I go to the laptop, I insert the IP. It does not find it. Where do you get the IP from? Is it the local IP or is it your external? All right, so now we've got the stack. And then we go through it. If the token is addition, we add. If it's subtraction, we subtract. If it's multiplication, we multiply. It's going good, bro. You know, just grinding for summer internships. Let's go. You're in school still? You studying CS? What school you go to? Interesting. Uconsa says IPv4. It's your IPv4 address. That still doesn't answer. Like, how did you get the IP address? Where did you find it from? So else if tokens is division. We divide, and we do it in the correct order. Otherwise, if it's not any of those operations, we know it's a number. So we push the parsed number onto the stack. IP config and CMD. Okay, that should give you the right IP address. Let's see. Where do you insert the IP address to in the laptop? I'm actually transferring to UC Santa Cruz this fall so I can be nice and deep in Silicon Valley. Ooh. Wow. How does transferring work? So did you have you applied there and they accepted you, and then like you have like a specific class set that you're gonna take when you transfer over? Yeah, I've heard good things about UC Santa Cruz. Also, is it normal that though both PCs are connected to the same network, they have different IPs? Yes, that is normal. So each device that's connected to a network needs to be have a different IP address. You just spit the IP in File Explorer. See, yeah, that doesn't completely work because you need to, the PC needs to be like listening for different requests. So you might want to set up like an FTP service on the computer that you want to get the files from. So let's see, FTP Windows. FTP Windows, FTP server. You want a server, because if you just have an FTP client, that's not gonna really help you. I'm just transferring as a junior, so when I get in, I'll be on the same course plan as every other junior there. Okay, cool. Oh yeah, so are you skipping any years or like losing any years there, or are you like gonna be are you like losing a year? Okay, so my question is, how are all the FTP programs ugly or unintuitive? I know, right, dude? Yeah. Oh man, that's true. They are pretty gross. Okay, so I guess Windows comes in with an FTP server. Transfer files from one PC using FTP. I just want the D to show in this PC. Yeah, I don't know if that's possible. I think you'll need to host like an FTP server on your computer. Set up FTP on the receiving PC. Connect to the remote PC. We want the remote PC to... Okay. WikiHow. All right. All right. This article will help you. You follow this article, you Kansa. Also, it was not the wisest idea of mine to ask you since you're on Mac. I have some Windows PCs as well, but Mac is my preferred. I grew up on Windows, dude. I grew up on Windows. And Mac is just so much, I love it a lot better for coding and stuff. But yeah, you follow that article. That article will tell you how to set up FTP, and then you'll be able to transfer your files. Okay, so we get a compilation error for this C# code. No, I'm not necessarily skipping any years by transferring, but I graduated high school early, so I'm only 18 now. Wow, dude. That's epic. So you're a sophomore in college and you're 18, dude? That's pretty epic. You got a head start, dude. And you're grinding Leetcode for summer internships, dude. Good luck with that. Oh man, the market's tough right now, but if you got a good head on your shoulders, you're gonna get in somewhere good. What companies are you looking at to intern at? Operator less than cannot be applied to operands of type int in method group. Is this not the right way? It's length, isn't it? It's tokens.length. Nice, accepted. All right, does it actually work if we submit it? Nice, baby. So we've solved this, what is even the question called? We solved this evaluate reverse Polish notation question in Java first, then C++, and then finally C#. So we've got our O of n solution, which is as recommended. Actually, I think this is less than O of n because we only store a maximum of 2 elements in the stack at one time. So this is a O of 1 solution, isn't it? Stack. All right, this is... Wait, no, time complexity O of n, space complexity O of n. Interesting. Yeah, it's tough. My main company right now is Amazon. I have a final round coming up, but I have yet to hear back from quite a few companies. Wow. So you have a final round with Amazon. Good job, dude. That's impressive. Good luck with your final round. I have a coding assessment with Amazon. So it's basically like the first round. Yeah, did you have to take a coding assessment for Amazon? How was that, if you did? All right, so we've solved these 3 questions under the stack category. I think it's time to move on. I think it's time to move on to, let's do binary search. Let's do this easy binary search question. You are given an array of distinct integers, nums, sorted in ascending order, and an integer target. Interesting. So this question claims the order of the nums is in ascending order. There was another question that said it was non-decreasing order, which isn't that the same thing? I wonder if there's some quirk to it. It was good. 2 medium questions, 1 easier, 1 quite a bit harder, but I passed all in like half the time. So I passed. By the way, is stream meant to be frozen? Is the stream frozen, dude? No, the stream is not meant to be frozen. Interesting. Huh. On my end, it's good. I don't know. Interesting. Weird. Okay, but 2 medium questions, 1 easier one. You passed in like half the time. Holy cow, dude. Good work. Oh, it just froze for me on OBS. Can you predict the future, dude? If you can predict the future, you should be able to get into any company you want, dude. So I want to find out what the difference is between ascending order versus non-decreasing order. Ascending order means arranging items from smallest to largest, where each element must be strictly greater than the previous one, while non-decreasing order allows elements to be equal to the previous one. And this question does mention that they are distinct integers, so that is ascending order. Hell yeah. So we get an array of distinct integers, nums. It's an ascending order and an integer target. Implement a function to search for target within nums. If it exists, then return its index. Otherwise, return -1. Your solution must run in O log n time. Okay. Log n. And it's sorted in ascending order. Okay, so target is 4. Is this your first Leetcode cycle? I see you're Leetcoding until employed. Yeah, well, yeah, this is the first proper Leetcode cycle. When I got my job in college, I had a coding assessment, but I don't think I really like grinded Leetcode for it. It was the questions were very easy though. But yeah, this is the first time I'm actually like grinding Leetcode and yeah, solving these problems. Yeah, this is day 3, baby. Also, I feel like maybe having Leetcode, like doing a Leetcode problem maybe once every week is probably a good thing, because the problems are hard. It keeps you sharp, you know? It makes you think of, it makes you really think. And I think thinking is a good thing to do once a week, at least. Okay, so running an O log n of time, my initial thoughts are we get the middle element of the array. Is it less than or greater than the target? Basically, just a binary search algorithm. So to start, let's have a pointer, int pointer, and we'll start in the middle. So it'll be nums dot size divided by 2. And we'll also have a counter, or a current element. And it'll be equal to nums pointer. Oh, I just noticed we're doing this in C#. I'd prefer to start this off in Java. So we've got this, and now while current element is unequal to target, we want to you know what? This is unnecessary. We could just do nums pointer. So while nums pointer is unequal to target, if nums pointer is greater than target, then we want to if we are past the target, we want to go lower. We start in the middle. So what we want to do again is probably divide the pointer in half again. Yeah, divide the pointer by half. Pointer divided by equals 2. Else, if nums pointer is less than target, we want to multiply. Wait, I don't think we want to multiply by 2. Because that'll bring us all the way to the end. We start in the middle. If it's less than target, we want to go in the middle again of that. So what is that? It's plus equals. Let's think about this a little more. So let's go through an example. So we've got our list. And we've got our target. So we start in the middle. So what is this? 1, 2, 3, 4, 5, 6. The size is 6, so divided by 2 is 3. So 0, 1, 2, 3. We start here. Is 4 equal to 4? It is. Easy. Easy peasy. Let's change this to, let's change the target to 2. So we start at 4. Is the target less than the pointer? Or 4 is greater than the target. So we need to move down. So how much do we move down by? So we are at 3. And the beginning is 0. So we do the current pointer divided by 2, say. So 3 divided by 2 is 1.5. In Java it gets truncated down to 1. So our new pointer is 1. So 0, 1. Okay, so now our pointer is 1 and the value is 0. So is 0 less than 2, our target? It is. So what do? We move up half in between 3 and 1. So 3 minus 1 is 2. Divided by 2 is 1. So we move up 1. What if this is where we started? Four divided by 2 is 2. No. It's 3 divided by 2. We move up. Oh my god. Probably an easy way to do this with recursion. Is backseating allowed, like hints, or do you want to do all your own? Interesting question. It's up to you. If you want to give hints, you're more than welcome. But I'm thinking taking a recursion approach to this. So we return an int though. So with a recursion, we split the array. 0, 1, 1, 2, 3, 4, 5, 6. So we do -1, 0. Yeah, I will say you have a good intuition, but you are trying to do a lot with just one variable. Maybe add some extra variables to help you. Interesting. Thank you, Jeter JP. Okay. All right, so if I think through this recursion way out, we'd get 2 function calls. Yeah, this is why I'm practicing these Leetcode problems, because if I'd be cooked if I was just taking the assessment and they came up with this question, even though it's easy. Oh. Oh man, all right. So have more extra variables to help. Okay, so all right, we'll have our pointer. Okay, our pointer. While num's pointer is unequal to target. All right, I don't think it can be unequal to target because there may not be a target. If that's the case, we need to output a -1. But some extra variables that might help are maybe positions we've already searched. If we use that, I could see this maybe going to an O of n solution. All right, so all really think recursion is the way to go for this because... No. What? You know what? Let's just code through the brute force solution. Maybe we'll figure out how to do it once we have the brute force. I is less than nums.length, I plus plus. If nums I is equal to target, return I. Return -1. Oh, this is Java, not JavaScript. All right, we've got the brute force solution. Oh my God. So the Don't Be Mad 4, thank you for the follow. I appreciate it. Welcome to the stream. Just trying to figure out this log of n solution. So basically what we want to do is like the phone book trick. You check in the middle. You're not you're too far off, so you rip it in half and you then search the first half of the phone book and you get the middle of it. Are you higher or lower? You're higher. So you rip the phone book in half and throw the higher part and look at the lower part. Let's think. Let's do Jimmy Neutron brain blast. So how do we keep track of... No, so... This is an easy problem. Why is it making my brain work so hard? Oh. Yeah, the phone book trick sounds accurate, and your first solution was kind of like that, but you didn't have a way to throw away the top or bottom half of the book. Okay. All right, let's get this while loop started. So we'll have our pointer, and we start in the middle. Okay. And so all right, so let's get the element. So nums pointer is our value here lower than the target? Well, let's check if it is equal to the target. All right. Okay. If num's pointer is greater than target, then we want to go to the lower half. Which means throw away upper half. So all right. Let's see, how do we throw away the upper half of the book? So we just want to move the pointer to the middle of the first half. Ah, so do we need an end variable? So int end, we need an int start equals 0, and we need a end equals. Thank you, Jeter JP. Okay, thank you. End is nums.length. So we throw away the upper half. So end is equal to pointer. Also, while start is less than end. If nums, I appreciate that hint, Jeter JP. You're the reason I'm getting somewhere now. I have hope now. So the end is equal to pointer. If num's pointer is greater than target, we go to the lower half, and we want to set the pointer equal to end divided by n divided by 2. Else, if num's pointer is less than the target, you want to throw away the lower half. So start equals pointer, and pointer so we throw away the bottom half, and now we want to set the pointer equal to the end minus start divided by 2. If none of these are true, that must mean that num's pointer is equal to target. So we return the pointer. Now, if we don't return the pointer at all, while this loop executes, then we return -1. All right. This seems right. So let's just go over this. While start is less than end, we check is the let's check it for this case, right? So pointer is equal to this length is 1, 2, 3, 4, 5, 6. So pointer is equal to 3. 0, 1, 2, 3. All right. If nums, and let's say target is equal to 2. So if pointer is greater than target, which it is, the end of the book is the pointer. Maybe we should do pointer minus 1. Yeah, pointer minus 1, because we don't want to check the same element that we've already checked, because we know it's bigger and it's not equal to the target. So the end is 0, 1, 2. And pointer is end divided by 2. So 2 divided by 2 is 1. So it's 0, 1. All right. Start is 0, end is 0, 1, 2. So we continue. The current value is 0 is less than the target. Yep, so start equals pointer. That should be pointer plus 1, because we know that that is not it. And pointer equals end minus start. So start is 0, 1, 2. Start and end is 2. So 2 minus 2 is 0, divided by 2 is 0. That's 0 divided by 2 is 0. Yeah, so this is a little flawed. To fix this, maybe we could have a case that checks if end is equal to start. Or figure out a better way. Maybe that's not the right way to calculate the pointer. So if we say the target is 6, target is 6. All right, so we start here. Target is greater than where we're at, so we start equals pointer plus 1. All right, so this is the start. Pointer equals end minus start. So what is this? 8 minus 2. I mean, what no? 8 minus 6. No, what am I saying? 0, 1, 2, 3, 4. So 5 minus 4 is 1. Divided by 2 is 0.5, which is 0. I think this needs to be plus pointer. Plus equals, all right. All right, let's run this. Oh, it passes both test cases. Sweet. Now if we submit it. Oh, we have an infinite loop. Interesting. Okay. So for this test case, 2 and 5. All right, so we start as 0, end is 2. Maybe n should be -1. All right, I just threw that -1 in there just for shits and giggles. But let's see. Let's follow through this test case. What happens? So our start is 0, our end is 2. 0 is less than 2. We go in. Also pointer is 2 divided by 2, which is 1. So 0, 1, we start here. Is num's pointer, is 5 greater than target? Target is 2, so yes, it is. What happens? We set the end to 2 minus 1, which is 1. And we set the pointer to 1 divided by 2, which is 0. Pointer is 0. Pointer is 0. Start is 0. End is 1. Let's just check if it's equal to. Also, if num's pointer is equal to target, return pointer. All right, so at this point, start is 0. End is 1. Start is less than end. True. Num's pointer. Oh, what's pointer? Pointer is equal to end equals pointer minus 1. 1, 2. 2 minus 1 is 1. 1 divided by 2. 0. So num's 0. Under 0. Num 0 is 2. If num's pointer is greater than target, no. Also, if num's pointer is less than target, is 2 less than target? No. Is 2 greater than target? No. Then it should return 0. Let's print pointer here. System.out.println pointer. What is pointer? This should be 0. It is 0. Okay, let's print start and end. Maybe we exit out of the while loop for some reason. Pointer is 0, start is 0, end is 0. End is equal to pointer minus 1. End starts at 2. 1, 2. Okay, so this is where the problem is. I think there is a general way to calculate the middle of a range. It seems superfluous to have 2 different logic for that. I think there is a general way to calculate the middle of a range. Correct. Seems to have 2 different logic for that. You're right, dude. You're right. And yeah, and minus start. Interesting. All right. All right, pointer equals n minus start over 2. That's the middle. Start equals pointer plus equal, just pointer equals. All right. Okay, but still we set n to 0, so n pointer. While start is less than or equal to end. We got an infinite loop for that case here. So it fixes this case, but it breaks this case. You have an infinite loop for this case. There's a better way to fix this. All right. Could also move this out. Refactor that. All right. Try to calculate the middle of 1 and 7 with your logic. Seven minus 1 is 6. Divided by 2 is 3. The middle of 1 and 7. Is that not equal to 1, 2, 3, 4? The middle of 0. Thank you, Jeter JP. That is incorrect. The middle is 4. So what? Huh, interesting. That I was calculating the average. How do you get the middle? Just 7 divided by 2. 7 divided by 2. I don't know. It has to depend on this. Oh my god. 7 minus 1 is 6. How the? You're almost right. You just have to swap an operator. It's okay to look up the specific equation for middle of the range since you need to know to do that. Why the hell don't I know how to calculate the middle of a range? What? Middle of a range. Why is that escaping my brain? Add the smallest and largest values together, divide the sum by 2. You add? What? What? Is this the first time I'm getting the middle of a range? Why is that concept foreign to me? You add this number and then divide by 2? Oh my god. Oh my god. Jeter JP, you're the man, dude. You're the man. All right. So we got the right equation to find the middle. That is important. That's very important. So we still have the start and end equal to 0. Now if we, oh my god, dude. Oh my god. Index 6 out of bounds for length 6. All right, we have another error. Okay. We got an index out of bounds. Interesting. So pointer is 1, 2, 3, 4. That was the initial pointer. This is probably incorrect as well. So one, 2, 3, 4, 5, 6 divided by 3. 0, 7, 1, 2, 3, 4, 5, 6, 7 divided by 2 would be 3. 0, 1, 2, 3. No, that's right. Divided by 2 is right. For the pointer to get the middle. Oh, the end is not. Let's go, baby. Jeter JP, I couldn't have done that one without you. Thank you for your hints, man. I appreciate it. That's kind of sad, though. That was an easy Leetcode problem. And it took me, what? More than like... Oh, man. It took me like 30 minutes. Maybe it felt longer. Let's go, bro. Well done. Jeter JP, that was all you, man. Thank you. Oh, man. I appreciate that. Let's go, dude. Finally. That's crazy. Man, it should not have taken me that long, but let's do it in C++ now. Let's go. So what we want is our pointer, and that is nums dot is divided by 2. We also want our start. It's equal to 0. And we want our end. That's equal to nums dot size minus 1. So while start is less than or equal to end, we want to check, is the target, is our current pointer greater than the target? If it's greater than the target, we want to throw away the upper half. So we do end equals pointer minus 1. Else, if the current element is less than the target, we want to throw away the bottom half. And then, if none of those cases are true, then it's got to be equal. We want to return the pointer. And then we want to change our pointer position to the start plus the end divided by 2. How did I not know how to get the middle number? That's crazy. I feel like that's basic math, dude. You learned that in 1st grade. Wow. Okay. So if that whole thing executes and we still haven't returned, we want to return, because that means we have not found the number. So just to reiterate, we got the pointer and we just put that in the middle. We got our start, we have our end, nums.size minus 1. That's our the last position available. So while start is less than or equal to end, we want to check, is the current element greater than the target? If it is, if it's greater, then we throw all that out and continue with the lower half. If the number is less than the target, we throw the lower half out and continue with a higher half. Otherwise, we return, if it's equal to the target, we return the pointer. Then we calculate the position of the pointer based on the start and end position. And then if none of that executes, we return 1. So let's run that in C++. Oh, first try, no compilation errors. Let's go. It's simple enough, though. It's simple enough. Submit. All test cases pass. Perfect. And now C#. Okay, so again, we need our pointer. And that's equal to nums.length over 2. We want our start position, which is 0. We want our end position, which is nums.length minus 1. All right. And while our start, Boskins, thank you for the follow, dude. We just achieved the 50 follower goal. Now we can be an affiliate. Let's go. Thank you. Let's go. Dang, Java and C++, you are the Fortune 500 legacy stack final boss. I know, dude. Yeah, I mean, the Amazon position that I'm applying for is I think Java, and the recruiter asked me, she was like, what object-oriented languages do you know? Because Amazon's big on object-oriented. So I was like, you know what, C#, C++, and Java, just because I wanna solidify my my chances, you know. But I think I'm gonna solve the coding assessment in Java. What did you end up solving the coding assessment in? Less than or equal to, and we want to check if the pointer if the current element is greater than the target. If it is, okay. If the current element is greater than the target, then we want to throw away the upper half. So we set the end to pointer minus 1. Else if nums pointer. I solved the coding assessment in Python. I do my projects in Python and I think in Python, but I do my schoolwork in assembly. What are you talking about? You do your schoolwork in assembly, dude. No way, dude. Yeah, Python is the popular choice for the coding assessment. My friend was like, "You're not doing it in Python, dude. What are you talking about?" I was like, "I just gotta show the Java part of me." But come on, dude. Schoolwork in assembly? What are you talking about, dude? No way. You taking an assembly class or like a lower level systems class or something? Because I can't see a professor making you write assembly, dude, for schoolwork. It's less than target. If it's less than target, then we want to throw the bottom half away. So we'll set the start to pointer plus 1. Otherwise, we know this is equal, so we can return the pointer. And we want to recalculate our pointer position to the middle range, which is equal to end plus start divided by 2. And we will return 2 semesters of straight assembly for computer architecture. Holy cow, dude. You doing anything cool in assembly? Return. We want to return -1 since we haven't returned already with a pointer. So let's run that. I didn't even check the code, so there's got to be a compilation error. Oh, let's go. No compilation error. First try, baby. Okay, now let's submit it. All right. There we've got our Java, C++, and C# solution for this easy binary search question. The solution is in O log of n time because we delete each half. Oh, you know just the stuff you can do in 40 lines in Python in 400 lines of assembly. Dude, that's tough, manipulating. So you're changing the registers and everything, huh? Manually. That's crazy, dude. You poor soul. One of my viewers, he made a assembly like simulator in Rust. He made it look really cool. I wonder what if I can find it. Let's see. I wonder if I starred his repository actually. Yes, CPU. I think I actually downloaded it as well. CPU. Viz. Let's see. I forget how to run it. I made a chessboard where all the colored squares changes colors n times and displayed the nth Fibonacci number on the nth colored square for my final, but that's about it. Holy cow, dude. Jeez. Yeah, huh, interesting. I wonder why the Fibonacci sequence is so popular with assembly projects, because this kid did a Fibonacci like simulator of what happens inside the CPU. How the hell do I run it though? Ah, forget how to run Rust code. All right, so let's see. / I wonder if I could just run. Oh wait, target is a directory. Rust C source main, and then if I pass in the Fibonacci, Rust C source main, whatever. I guess I forget how to run it. Damn. Oh well. All right, so what do we in binary search? We have search a 2D matrix. That easy binary search problem gave me all that trouble. This one I'm going to explode on stream. You are given an m by n 2D integer array matrix and an integer target. Each row in matrix, excuse me, is sorted in non-decreasing order. So we can have duplicates in this array, but we know that it goes up instead of down. This is my capstone project. I just opened it on GitHub. Bang programming language. Oh, you made a programming language for your capstone project, dude? Bang. Let's start this repository. Bang is an interpreted procedural programming language for algorithmic design prototypes or small-scale projects. Interesting. Bang was created with an emphasis on the developer. It is meant for developers to prototype algorithms, functions, programs, etc. rapidly and then translate into a more robust language. Interesting. So we've got features, we've got types, you support Boolean, integer. Did you actually implement this or did you just come up with a specification of it? Float data types with strings on the horizon. Okay. Expressions, robust mathematical and logical expressions. So we got all these operators. Okay. Dang, dude. Very dynamically typed. Uh-oh. Uh-oh, dude. Dynamically typed. I don't know. A lot of people don't like dynamically typed. They like their statically typed programming languages. Variables can be used anywhere. A constant value is allowed. Nice. I wrote it in 800 lines. You can write the language in a file, and it will execute. No way, dude. Wow. Bang supports conditional expressions with the if, elif, else, and if. So sort of like Python. Okay. Example code. N equals 15. Sum of numbers 1 to n equals 0. For I, n, sum of numbers 1 to n equals sum of numbers I to n plus I, and if. Oh! This is cool. Very compact syntax for IN. You got your nested if statements as well. No colons or semicolons, huh? Wow. Wild temp, yeah, no colons, huh? This is like Python, but even less syntax. Cool, dude. This is sick. You got 2 branches? Ah, you got 2 branches. Ooh. So is this Bang compiler? This is the Bang compiler, huh? It's written in Python. Hell yeah, dude. Nice work, dude. That's epic. How long did this take you? You said it's your capstone project. Is that like a high school capstone project or college? So each row in matrix, each row, boom, non-descending. Okay. The first integer. Oh, it's just a personal project, but I've worked on it on and off since November 2024. Wow, dude. Nice work. What inspired you to make your own programming language? And why'd you call it Bang? You are given an m by n 2D integer. Okay, we got that part. The first integer of every row is greater than the last integer of the previous row. Okay, so the whole thing is sorted. Return true if target exists within matrix, or false otherwise. Can you write a solution that runs an O log of m times n time? I think I can. Okay, so instead of just a 1D matrix like that other problem was, this is a 2D matrix. So we gotta just alter the code. Well, it goes back to having to write. Excuse me. Well, it goes back to having to write C++ and assembly in school. I'd always prototype my algorithms in Python and then translate into lower level. So I decided to make a language specifically for that function. Oh, wow. Interesting, dude. Wait, so this, you're telling me this translates from your language into C++ and assembly? So it's basically a way for you to, no, it doesn't compile to assembly or C++, but it's like really easy to read to translation. So it just makes it a lot easier to translate. I see. That's epic, dude. Way to go. That's the best part about programming. You can make your own tools to make your life a lot easier. And you did that with this Bang project. Prototype your algorithms in this language, and then you make it a lot easier for yourself to translate. And it's called Bang because you're supposed to be able to write programs in a Bang. Oh, Kriegasm, hell yeah. Oh. All right, so this is a little trickier than the other one. So what is the difference? Because this 2D array could just be one long array. Let's switch this to Java. So the size of this array is arbitrary. So int m equals matrix dot length. Int n equals matrix 0 dot length. 1, 2, 4, 8. Okay, And then we could get the total size. Int total length equals m times n. All right, and say we want position. So you want 0, this is 0, 0. This is 0, 1. 2. Okay. So basically we need to convert. So say we want position 3. To convert that into coordinates, it would be 0, 1, 2, 3. Okay, so I'm sort of seeing how this can work. Int start equals 0. Int total length is, let's just call this end. Let's move this down. Equals m times n minus 1. All right. So it's basically like the same thing as the other one. While start is less than end, less than or equal to end. If so this is where it gets complicated. Oh, we also need our pointer. Pointer equals end divided by 2. So now we have a linear pointer, and we need to convert it into a 2D pointer. So I think my brain will come up with that if I type this out. So that's the less than target. Okay. Or if it's greater than target. Okay, so how do we calculate the pointer, the real pointer, from the linear pointer? So 1, 2, 3, 4, 1, 2, 3. So this is 12. 12 divided by 2 is 6. So 0, 1, 2, 0, 1, 2, 3, 4, 5, 6. So how do we turn 6 into 1, 0, 1, 2, 1 to 1, 2? That by doing pointer mod is it m or n? We do that by doing pointer mod 0. So this is 4. So 6 pointer mod 4. So it's mod n. Okay. Wait, no. It's divided by n, not mod n. And then this is pointer mod n. All right, let's see if this works. If that's the case, if the current position is greater than the target, then we've overshot and we need to remove the last half. So pointer, no, so we just set end equals to pointer minus 1. Else if matrix pointer divided by n pointer mod n is less than target, then start equals pointer plus 1. Else return pointer. Oh, what do we need to return? We need to return true. Return true. Otherwise, return false. Also, we need to change the pointer. Pointer equals start plus end over 2. Yeah, whoops. No way. It worked first try. It worked first try. Holy cow. Let's see if we submit. Will that still work? No way, dude. This was a medium problem? This was a medium problem? This wasn't bad at all. Holy cow. Let's go. All right, so we got the brute force, which we've got 2 for loops O of m times n. Then we got the staircase search. What the hell is a staircase search? Which is O of m plus n. Then we have a binary search. While top is less than or equal to bottom. All right, target is greater than matrix rows calls minus 1. Binary search 1 pass. Is this what I did? Yeah, this is what I did. Let's go. Oh. All right. So, thank you everyone for joining. I appreciate you guys. Thank you, JP, for the extensive amount of help you gave me, especially with that binary search problem. That was easy. Gave me a lot of trouble. Thank you for that help. APU, it was good talking to you. Thank you for coming by. UConsa, thanks for stopping by. APU, wait, did I just say APU? Yeah. Thank you for stopping by, APU. It was fun chatting with you about your intensive startup work. Kabir Singh, thank you for stopping by. Baigan, thank you for stopping by. Yeah, now let's raid somebody. Interesting. Who should we raid? We got someone play seeking adventure. Lakshay, thank you for the follow. I appreciate that. Let's go. All right. Oh, APU is streaming. No way. Let's raid him. Let's go, baby.